Next, let's take up a couple of more intricate concepts involved in inequalities. There are 4 examples that we would like to discuss here. First one, x minus 3 whole cube into x plus 3 whole square is less than or equal to 0. Prima facie, one would be inclined to think that this is the same as x minus 3 into x plus 3 is less than or equal to 0. However, that would be a mistake. The thing that you need to observe here is that as far as x plus 3 into whole square is concerned, this is always greater than 0. If x plus 3 whole square, because it is a perfect square, all perfect squares would be greater than or equal to 0. So x plus 3 whole square is always greater than or equal to 0. So that means that whenever x minus 3 whole cube, this portion is less than 0, less than or equal to 0, this overall thing would become less than or equal to 0. There is a catch there, I'll come back to that. Now if x minus 3 whole cube is less than or equal to 0, that effectively means that x minus 3 is less than 0, because the cube root, the cube of a negative number will be negative, a positive number will be positive, so and vice versa. So this means that this can be simplified as x minus 3 is less than or equal to 0. If x minus 3 is less than or equal to 0, that means that x is less than or equal to 3. So x is less than or equal to 3, that will be the solution to this. The important point, one more thing that you need to keep in mind here is that x plus 3 whole square, you cannot completely ignore it. You will also need to take into account that because it is less than or equal to 0, the value of this is greater than or equal to 0. So from here, x equals to minus 3, that will contribute to this, because at that point this overall value will become 0. So therefore, if x equals to minus 3 was not there in the solution, then that would have had to be included separately. Let me elaborate. Try this. In this case, naturally this portion is always greater than or equal to 0. That means that x minus 3 has to be greater than or equal to 0. That means that x has to be greater than or equal to 3. However, x is greater than or equal to 3. Along with this, there will be one more point that will satisfy the condition, that will be x is equal to minus 3. Because x equals to minus 3, this thing will be equal to 0. If this is equal to 0, this whole condition that will also become true. So therefore, in this case, the answer will be x equals to minus 3 union. It goes from plus 3 to infinity. So plus 3 to infinity. So this will be the solution, a very important learning. You must pause this video, go through this portion again and understand it very clearly. That's number 1. On the other hand, if it was greater than 0, then the answer would have been very simply plus 3 to infinity. This point would not have been included. So that was the first point, first one. Second one. X square plus 2x plus 7 is less than or equal to 0. If x square plus 2x plus 7 is less than or equal to 0, first thing is that if you try to find the factors of x square plus 2x plus 7, something that we have been doing so far, it will not be possible, because x square plus 2x plus 7, it will not have any real roots. It will have only complex roots. So therefore, it is not possible for you to find the factors. If you cannot find the factors, it cannot be written in the form x plus alpha into x plus beta, which means that the normal method that we have been using so far, that will not work. Therefore, you need to observe something here. This can be written as x plus 1 whole square plus 6. Check from here, x square plus 1 plus 2x. So plus 1 plus 6 will become 7. So this overall thing becomes x plus 1 whole square plus 6 is less than or equal to 0. Now naturally, x plus 1 whole square, this is greater than or equal to 0. If this is greater than or equal to 0, plus 6 will be greater than or equal to 6. Because it is greater than or equal to 6, that means that definitely this portion, it can never be less than or equal to 0. Which means that there will be no solution. So in this case, there will be no solution. 5 is your answer. If I was to not put it this way, if I was to try finding the solution using the quadratic equations approach, what I would have done is, let me first try to find the roots of x. X is equal to minus b plus minus under root of b square minus 7 4s are 28 upon 2a, so upon 2. Now 4 minus 28 is a negative number. Because it is negative, the square root of this will be negative, which means that there are no real roots, and if there are no real roots, this will not have any real solutions. So that would have been about it. Third one, x minus 3 upon x plus 1 is greater than 0. If x minus 3 upon x plus 1 is greater than 0, how do we approach this? In this case, what you will have to do is, whenever a upon b is, let's say for example, instead of 0, let me make this 1 in order to complicate your life. If a upon b is greater than 1, so from here, can I say that a is greater than b? It is not necessary. It is not necessary. It is not necessary because if I write a upon b is greater than 1, let's say 3 upon 2 is greater than 1. In this case, definitely 3 is greater than 2, but also minus 3 upon minus 2 is greater than 1, in which case minus 3 is not greater than minus 2. So therefore, on the basis of this, this can not be said. It may be true, it may not be true. The solution for this problem is, what you need to do is, if a upon b is, let us say, greater than 1, here you multiply both the numerator and denominator by b. So this will become a upon b into b. So this becomes b square. Let's say this is more applicable when it is equal to 0. So from here, this will become a upon b square is greater than 0, which means that from here b square is definitely greater than 0. If b square is definitely greater than 0, effectively a upon b should be greater than 0. Now if a into b is greater than 0, whether both are positive or both are negative, in both the cases this condition will be true. So that will take care of your problem. Let's take a look at this one. X minus 3 upon x plus 1 is, let's say, in order to complicate your life a little more, this is less than 0. If I make this less than 0, so from here we will directly get x minus 3 into x plus 1 is less than 0. For the sake of solving the inequality, on the number line I will get minus 1 and plus 3, which means that the solution will lie in the range, if you can check for 0, this is minus 3, this is plus 1, overall the condition is satisfied, so this is true, this is false, this is false, minus 1 comma 3 is your solution. Now the question is whether these 2 points, they will be included or they will not be included. In this case, because it is less than 0, I do not have to, or over here also, because it is less than 0, I don't have to include these points. So here the solution is easy. It will be minus 1 comma 3. However, if it was like this, then the story would have been different. In case it is like this, in this case, the solution will not be minus 1 comma 3 like this. This would have been wrong. The solution will be minus 1 comma 3. The reason being, because it is a upon b, b can never be equal to 0. Because if b is equal to 0, this will be not defined. If b cannot be equal to 0, x plus 1 is not equal to 0. So x is not equal to minus 1. So therefore minus 1 is not possible. So that will have to be excluded from the solution. If x plus 1 whole square is greater than 3, I will say x plus 1 whole square minus 3 is greater than 0, which means that x square plus 1 plus 2x minus 3 is greater than 0, which means that x square plus 2x minus 2 is greater than 0. Now what will be the values of x that will satisfy this condition? We would not know. Because we would not know, so what we do from here is that we find the roots of the equation using the method for quadratic equations. X is equal to minus 2 plus minus under root of 2 to the 4 plus 4 to the 8 divided by 2. 4 plus 8 is 12. 12 square root will be 2 root 3. So this will become 2 root 3. If this becomes 2 root 3, so x is equal to minus 1 plus minus root 3. If x equals to minus 1 plus minus root 3, I'll put it like this: minus 1 minus root 3, this is one point, minus 1 plus root 3, this will be the other point. If I put x equals to 0, at x equals to 0, this is minus 2, the condition is not satisfied. This will be my solution, this will be my solution. So minus infinity to minus 1 minus root 3, and plus minus 1 plus root 3, 2 plus infinity, that will be the range of values of x that will satisfy this condition. There would have been one more method actually. If I simply from here, if I take the square root, x plus 1 is greater than or equal to plus minus root 3. So that would mean that x is greater than minus 1 plus minus root 3. That will have directly brought us to this. However, what I wanted to illustrate here is this method of calculating the roots of a quadratic equation and then substituting that here in order to find the general solution. Next, before we move to the next section, I would like to discuss one shortcut method for a particular type of inequalities that you would be seeing very frequently. If let us say I have x minus a into x minus b is less than 0. In the other scenario, I have x minus a into x minus b is greater than 0. If it is less than 0, then the solution is a comma b within this range. On the other hand, if it is greater than 0, it will be outside of this. So minus infinity to a union b to infinity, assuming that a is less than b. So just remember this: when it is less than 0, it will be within the range. When it is greater than 0, it will be outside the range in the case of quadratic equations. Because most of the times the inequalities that we will see, they will be in the form of quadratic equations. Therefore, this method will come in very handy. So when it is less than 0, it will be within. When it is greater than 0, it will be without. Without means outside. So when it is less than 0, we'll take a comma b. When it is greater than 0, minus infinity to a union b to infinity.